Good day, grade 10 learners. Welcome to our mathematics lesson. I am Sikhulile Ncube, and this lesson is proudly brought to you by the Gauteng Department of Education. Okay, grade 10s, we're going to continue with our lesson. Remember last week lessons, what did we learn? What did we learn last week? Anyone who remembers? We introduced what? The function concept. Do you remember that? What did you learn about the function concept? We learned that there are input values that are changed by the function to get the output values. What's the other name for input values? They are the input values are the independent variables. Okay, the output values are the dependent variables. We say the input values are the domain. The output values are the range. And we said the input values are the x values. And then the output values are the y values. Do you remember that? We're going to use that in today's lesson. Remember that. So now today I'm going to be concentrating mainly on the x values and y values. Remember, the x values are the input values, and then the y values are what? Are the output values. X values are the domain, y values are the range. Remember that, okay? Right. So today we're going to look at what we call the quadratic function. The quadratic function. And I want you to be ready for the lesson. This is what we're going to be doing today. We are going to be what? To be plotting what? To be plotting the graphs. So we need to have our pens, our rulers, our pencils, and our books. Especially if you can get the quad book, the math book with squares. That would be great. So now, while I'm introducing the lesson now, you can make sure you have those things. If you can get them, that would be fine. The math paper with squares, we're going to be sketching graphs. We're going to be sketching graphs using point by point. Okay, if you can get those things while I'm introducing the lesson here, that would be great. Let's do that. Make sure your paper, the one with grid, even graph paper is fine. Okay, you can have those things with you. And then when you start plotting, your things must be ready. Okay, let's do that. Right, why are we learning about these functions? Some of you sometimes wonder, why are we learning mathematics? Do you know that mathematics is used in real life? That's why mathematics is needed in engineering and all these other careers. If you want to be an engineer, you want to be anything else. I'm just thinking about the engineer now, but there are a lot of careers that you need mathematics, okay? Right, so we have these things. Parabolic functions are frequently used in physics and engineering for designing structures. You see these structures that we have. They use mathematics, okay? We have structures like this. This looks parabolic. Remember, quadratic function also, they're called parabolas. Okay, this look parabolic. You see when you talk about the shape of the function, it's going to look like this. You need mathematics to come up with these shapes. Okay, some of you have gone to Quadratic City, you have seen things like this. These are designed by people who did mathematics, and then is used in engineering and designing structures. So it is very, very important. Okay, right, are we ready with our materials now? Let's start. Sorry, people, I forgot to remind you about the WhatsApp. The number is 060, take note, 060 667 5044. Okay, right, 060 667 5044. Okay, right, now let's do that. Now let's go to the objectives. At the end of the lesson, you're going to perform a point-to-point. You are going to do the point-to-point plot of the graph of y is equals to ax squared, where a is an element of real numbers and a is not 0. The coefficient of x squared here cannot be 0. Okay, right. Now discover the shape effect of a. Discover the shape effect of a. That's what we're going to do today. We are going to discover, we're going to talk about it after we have sketched. Then we say, what shape are we seeing here? Okay, and then we are going to discover the shape domain. Say domain is what? Input values, the x values. Range, the output values. The y values. The axis of symmetry. You know the line of symmetry? You did the line of symmetry long back. Right, turning points and intercepts on the axis. Okay, pre-knowledge, we've done function notation, and also we've done domain, the input values, range, output values, and then these are the x values, the range is the y values. Remember that, okay? Function notation, let me remind you. Let's say if you have y is equals to 2x squared, okay? Right, in function notation, we say f of x is equals to 2x squared. You see that f of x is what? Is 2x squared. We have replaced y with f of x. So today we're going to be seeing f of x. You're going to see g of x. It's just the same thing. It's like naming the graphs. Okay? 2x squared, or even h of x is equal to 2x squared. So instead of using y is equals to, we're going to be using f of x is equals to, g of x is equals to, h of x is equals to. But this f of x, that's your y. This g of x, that's your y. This h of x, that's your y. Okay? Right. Okay? Now, we usually start with this an easy activity. Given the function f of x, you see, I've replaced y with f of x. Given the function f of x is equal to 2x plus 3, fill in the table below. Okay, I want you to do this activity in 1 minute. I'm going to give you 1 minute. After 1 minute, I'll show you one of them, and then I'll give you 2 minutes after that, okay? Right, those who know, you can do everything. If you're not sure of what to do, just try. After 1 minute, I'll show you, then you continue with the rest. Let's do it in 1 minute. Welcome back, grade 10s. Our WhatsApp number is 063 629 3655. I hope I gave you the correct number now. 063 629 3655. That's the number you must use. Please send us your questions. Send us your input. Okay, so that we are together. Let's interact during the lesson. Right, what did you do, grade 10s? Let's see. How do we get f of x? We use substitution, okay? We use substitution. So what we do here, let me write the first one, f of x. When x is -2, what do we do? Where there's x, we put -2. So it's going to be 2 times -2. You see that the importance of brackets. If I leave it like this, this looks like 2 minus 2, isn't it? So I have to put whatever I'm substituting inside the bracket, and it becomes plus 2 times negative 2 plus 3. What is 2 times negative 2? It's negative 4, isn't it? What is negative 4 plus 3? It's negative 1. Okay, negative 1. Negative 1. So negative 2 will give us negative 1. So you see, the input value, which is the x, is put into the function by substitution, and then it comes out as the y value. Okay, it's now the output value is what? Is negative 1. Do you see that? That's what you're supposed to do. Let's do the rest in 2 minutes. Welcome back, grade 10s. Are you managing? Please send us your input. Is it easy? Is it difficult? Please tell us so that we help each other. And if you want us to explain something, want me to explain something to you, please send the questions. 063 629 3655. Okay, let's mark our work. Okay, if you got this one correct, it's fine. Now let's substitute negative 1. Where there's x, we put negative 1. So f of x is equal to 2 times negative 1 plus 3. What is negative 2 times negative 1 is negative 2. What is negative 2 plus 3 is 1. Okay, so it's 1. So we put 1 there on our table. And then we go to the next one, f of x. I'm not going to do all of them. After this one, I'll just give you the answers. Then 2, 0, and then plus 3. You see that? And then what do we get? What is 2 times 0 is 0. And then 0 plus 3 is 3. Okay, so where there's 0, we put 3. Let's mark that, okay? Let me give you the answers for the rest. So where there's x, you put 1, becomes 2 times 1 plus 3. What is 2 times 1 plus 3? It's 5. Mark that. And then if x is 2, where there's x, put 2, is going to be 2 times 2 plus 3. What is 2 times 2 plus 3? Is 7. Let's mark that. And then the last one, let me do the last one. So it's going to be, actually, I've done something wrong here. If I'm substituting, isn't it, this is f of x is equals to 2x plus 3. Now, if I'm substituting 3, where there's x, I put what? I put 3. So it means it becomes f of 3. Okay, f of 3. You see that? We have replaced x with what? With 3. Okay, f of 3. And then it becomes 2 times 3 and then plus 3. I really hope that also you got help there in the classroom. Okay, right. So f of 3 there and then becomes 3 times 2, which is 6, plus 3, which is what? Which is 9. You see that? Please take note of that. So here is f of negative 1. Here is f of 0. Here is f of negative 2. Okay, correct that. Okay, right, mark that. Any questions? Please send your questions to this number 063 629 3655. We've done our baseline activity. Let's go to the interesting part. You're going to learn something new today, great test. I'm so happy that you're going to learn something. Some of you maybe have done this in the classroom, okay? It's sort of revision, isn't it? Okay, yeah, let's do it together. Right, point-to-point plot of the graph of f of x is equals to ax squared. Let's use this nice example. It's a nice example. Right, it's given f of x is equals to x squared. It is in this form, but I can't see a there. Do you see a there? What is the value of a in this function? Here, the coefficient of x squared. Do we have any coefficient of x squared? Do you have an a? If you look at this function here, this one that I've given you, f of x equals to x squared. Do we have the coefficient of x squared there? What is it? It is there, isn't it? It is what? The invisible one. Okay? There's an invisible one here. Remember that, okay? Invisible one. So it means our a is 1. So we're going to use this function to sketch our graph point to point. I'm going to give you steps that you can follow. Okay? Right. Now, this is a very, very crucial graph. These other graphs are going to come out of this graph. Sometimes we call it the parent graph. We're going to be doing the translations and transformations of this function. Okay? It's going to be shifted upwards. You'll see later. It's going to be shifted sideways, horizontally, but not this year. To this year, we're just shifting up and down. We're going to talk about that one later. Okay? But this is the parent graph. It's going to be wider, it's going to be narrower. We're going to talk about that one today. Right, now we say a is 1. So what you do, step number 1, what you do, set up a table of values, just like we did in our baseline activity. Okay, right, I'll give you time to draw the table of values. Right, let's do that. Now this is the table of values. Please copy this table. I'm going to give you 2 minutes to copy the table as it is. This table. Please copy the table. Copy it to your book. Let's do that. Right, welcome back, great turns. Did you manage to sketch the graph? I hope some of you finished very fast and you started getting your output values, your f of x. Did you do that? Okay, right. What's the next step? Now, the next step, we use the equation of the function to determine f of x or the y values. Okay, our equation is f of x is equals to x squared. We have to use our equation now to find our y values or our f of x. I'm going to give you not 1 minute, it will be too short. 2 minutes. 2 minutes to try to find what? To find the y values. But before I give you those 2 minutes, I want to show you how to do it. Okay, just like we did with the baseline activity, where there's x, we put what? We put our input value. Let's start with this one. Right, our input value here is going to be f of -2. So where there's x, we put -2. Every time you substitute, put brackets. So it's going to be -2 squared. What is -2 squared? -2 times -2. You can even use your calculator. It's +4, isn't it? That's +4. Now, can you use 2 minutes to find the rest of our output values or our f of x? 2 minutes. Welcome back, grade 10s. Did you manage to get the answers? Let's see. Let's mark our work. Now, f of -1. What is f of -1? Where there's x, we put -1 is going to be -1 squared, which is equals to 1. Right. And then we have f of 0. Where there's 0, where there's x, we put 0. What we get? We get 0 squared, which is equals to 0. And then we have f of 1, which is equals to 1 squared. You see, I'm using this function. So 1 squared, which is equals to 1. And then we have f of 2, which is 2 squared, which is 4. Right. Okay. Remember, in our previous lesson, grade 10s, we said that we can use these representations interchangeably. Which representations are you talking about? We talked about the tables. We talked about the ordered pairs. We talked about the mapping diagrams. We talked about the graphs. Do you remember that? Okay? Even the formula. Now we have the formula here. You see that? We have the table here. Now we can even write these in ordered pairs. Do you remember that? X, Y. Remember, ordered pair will be x coordinate and y coordinate. Do you see that? So what will be the ordered pairs for this input and output value? Is going to be -2, 4. -2 is your input value x, 4 is your output value y. We come to this one, ordered pair, -1, 1. The input value is -1, the output value is 1. X is -1, y is 1. We come to this one, 0, 0. You see that? Okay? You see how mathematics work. Mathematics will always be, it's a cumulative subject. What you learn now, you're going to use it in the next lessons or in the next grade. You see that? Okay? Right. Now, and then 1, 1. You see that? Make sure you understand each and everything, because you're going to need this in your next lessons and in your next grade, in grade 11. And then you're going to also need it in grade 12. Okay? It is very, very important that you understand everything you learn in mathematics. Okay? Right. Now, let's move on. We have our table and we can see our ordered pairs here, because we're going to plot today. Right. Now, step 3, I want us to draw the Cartesian plane. Okay, like I said, if you have the paper with squares, that would be great. But if you don't have that paper, don't worry. I'm going to show you how to sketch your Cartesian plane. Cartesian plane is our x and y axis. Okay, we have our book. Someone has a book like this. It's still okay. Okay, let's do it together. Now, let's draw our y axis. Let's do that. Okay. We're drawing the y, not the y, sorry, I'm making mistakes today. Right, the x-axis, the horizontal axis is what? The x-axis. That's where our x is, the independent variable is. Right, let's draw that. Let me draw also, so that I know that I've drawn mine. I don't have a ruler, sorry for that, but when aside, you must have what? You must have your ruler. Remember, your work must be neat. Right, I've drawn the horizontal axis, the x-axis, so it means also you have drawn it there. Let's draw our y-axis. Use a ruler. Okay, right, good. That's our y-axis. Write y, and don't just write arrows without naming them. You must write x and y. Right, now let's put our origin. Put the origin by, this is the origin. The coordinates of the origin are what? x0, y0. So 0, 0, like this one. This is the origin, 0, 0 there. And then put your 1 there. That's the positive side of the y-axis. Put your 2. Let's do that. Put your 3. Put your 4. Please don't be left behind. We don't have time to lose. Don't make sure that you just follow this. You lose a minute, you'll be behind, and then you're going to be frustrated, isn't it? Let's make sure we move together. Right? -1, right? -1. -2. Try to make sure your spacing is what is even, is the same between the numbers, the coordinates. And then -3 and -4. Okay, right. And then this is the y-axis, and then we have the x-axis, 1, because our input values start from -2 to 2, so up to 2 is fine. So we have 2 there, it's okay. Even if you want your diagram to be big, make it big so that you can see what is happening. And then beside -1 and -2. So all of us now have our Cartesian plane, okay? Right. Okay, so on this one, so we're going to draw 2 graphs on this one, on this Cartesian plane, okay? Don't draw another Cartesian plane. You wait for me till I tell you to draw another one, okay? So we're going to have 2 graphs here. We analyze those 2 graphs, and then we move on to the next part, okay? Right. Now, I hope everyone is done now. Let's try to move on. Okay, good. Now, let's plot our points. The interesting part. Let's plot our points. Right. And then what are the coordinates here? The ordered pair here is -2. Let me write at the top here. -2 and 4. Do you know how to plot this point? -2 is x. So you go to your x, -2. Do you see that? And then your y4 is here. Do you see that? Okay. Then you draw your line. You don't draw a line. Dotted lines are fine for now. Dotted lines. Dot, 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 dot. Goes there. Then another one. Faint dot so that it doesn't spoil your graph. Then there. Where do they meet? Here. Put a point there. We have plotted a point. That's how we plot points. -2 and 4. We've plotted our point there. Do you see that? Oh, this is spoiling everything here. Okay, it's fine. It's fine. It's okay. Right. Now, that is that. We've plotted our point. That is -2, 4. Let's go to the next one. Is this one -1, 1? Let me write here so that it doesn't. Okay. -1, 1. Try to plot your -1, 1. You go to -1. Where is -1? It's here. Where is 1? It's here. And then dot, 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 dot. Where do they meet? Here. Okay? And then you put your dot there. That is -1, 1. Okay? And then we go to the next point. What's the next point? The x coordinate, 0. The y coordinate, 0. So it's 0, 0. We said 0, 0 is what? I gave you a name for this point. What is it called? That's the origin. That's the origin where the x-axis and the y-axis meet. That's the origin. So we're going to plot that point there. You see that? That is 0, 0. Okay? Right. Let's go to the next point. 1, 1. Now you should try to plot these last 2 points. Let me give you 30 seconds. I'm not going to go anywhere. Okay, I'll wait for you for 30 seconds. Try to plot this point and this point for 30 seconds. Right, I hope you're done, cretins. Let's do it together. Right, this one is the point 1, 1. You see that? Then where's point 1, 1? It's here. 1, 1. The point is here. Okay? Right, and then the last point is 2. X is 2. Y is 4. X is 2. Y is 4. The input is 2. The output is 4. Okay? Right, so where do you put 2, 4? Here. You see that? Okay. Right, what do we do now after plotting our points? Okay, some people find it difficult to sketch a parabola. A parabola is symmetrical. Remember that, okay? It's symmetrical. There's a line of symmetry. So what you can do, the left arm, draw to the origin, and then the right arm, which one is left? This side. Left, draw to the origin, right, draw to the origin. Okay, the arms, just right arm, left arm is fine. If you can, is giving you problems. Okay, right now, and then that will be the last part where we're now sketching our graph. Join the plotted points using a smooth curve. I know the curve won't be smooth there. Okay, right, but try your best to make sure that you have a smooth curve, and then we have a curve like that. You see that? Some people just do this. Draw your arm this side, go there. Then you draw your arm this side, you go there. Okay, the arms must be the same. Okay, but opposite, like reflections of each other. Right. Well done. Do you have a graph like that? What do you see here? I want us to talk about this before we add another graph. What do you observe? What is the shape of a quadratic function? What shape do you see? The shape is parabolic. That's why it's called parabola. It's cup-shaped. Cup-shaped. U-shaped. Okay? Shaped like this. It's a cup. You see that? Okay? Right. Where is the turning point? We're going to talk about that. Okay, but it turns here. That's the turning point. Right. If you check, I have arrows here. An arrow and arrow there. Why the graph does not end there? Why should we put these arrows here like this? Why should we put these arrows like that? Why? What do you think? Because the graph does not end there. Okay? It ends there because we just put the input values of negative 2 to 2. But we can put input values of negative 100 or even minus 1 million. We can put an input value of 100 if you want, of 150, of 1 million. In fact, we can put values from negative infinity to infinity. So that's why we're putting arrows there, so that the graph, it shows that the graph does not end there. So for graph, you put what? The arrows at the end. Don't just draw your graph like this and then it ends there. No. Okay? You put arrows to show that the graph continues. Okay? Right. Now, we have seen the shape of the graph. Okay? Right. Let's move on to, let's call it F. The graph is F. Now, I want us to draw another graph. And then we're going to compare this graph. Sketch the graph of g of x. It's just the same name. It's only that we want to see that there are different graphs, okay? But now a is negative what? Negative 1. Using the table method. Right, sketch the graph of g of x is equal to negative x squared on the same axis with what? With f of x. I want this graph to be on the same axis, okay? Right, now, we have done the plotting. I want us to observe things now. So I'll be moving fast in the plotting part because we now know how to plot. We have spent a lot of time on plotting, okay? So now, so that we can learn other things, let me move fast on this part of plotting. So we're going to substitute into the function. We're going to substitute our input values, okay, like we did. Let me just do 1. G of x is equals to negative 1, negative, which is this negative, this one, and then negative 4. Where there's x, you put negative 4 squared. You see that? And then you will get what? What did I do here? The input value is negative 2, so it's negative 2 here. So negative 2 squared is 4, and then times the negative 1 here is going to be negative 4, okay? Right. You put negative 1, you get negative 1 from this function. You put 0, you get 0. You put 1, what are you going to get? Let me do 1. F of g of x, sorry. G of x is equals to negative and then 1 squared. What do you get? Negative 1. And then you put 2. What do you get? Negative 4, okay? Right, I'll give you 1 minute to copy the table. Please don't draw this graph. We already have this, isn't it? We have done this graph. So don't draw it. Just copy the table for g of x for 1 minute, and then after that we do the plotting. If you can do the plotting before I show you, please go ahead. Don't wait for me. Just after drawing your table, go ahead and plot your points. Let's do that. I'm going to give you 1 minute. Right, welcome back, grade 10s. Did you manage to plot? Okay, welcome back. Sorry for that, grade 10s. Did you manage to plot the graph? Okay, right, now let's do it together. Right, we have the negative 2, negative 4 there. I'll just do what we call this, ordered pair. Negative 2, negative 4. You see that? Where is negative 2? Negative 2 is here. negative 4 is here. You see that? Then we plot, no, we're not plotting, just dotted lines, faint ones. And then where do they meet? The points will meet here, and then we plot our point there. It's -2, -4. I'm using a different color. If you have a different colors, you can also use them so that you can see your graphs, okay? Right, and then -1, -1, that's the next point. This one is going to be -1, -1 is here. So we plot that point, that's -1, -1. Then 0, 0, the origin is there by the origin, 0, 0. And then 1, 1, this point, 1, not 1, 1, 1, -1. 1 giving us -1. So this is 1, -1. Okay, that's a point there, 1, -1. And then we have 2, -4, which is this point, 2, -4. See that? That's 2, -4. Okay, can you see my faint lines? 2, -4. Okay, that's that. And then we can sketch our graph there, and then this is our graph of g of x. Okay, so now we have the two graphs, f of x and g of x. We have seen the effect of a. The black graph f, our a was +1. The blue graph g, our a is -1. Can you see the effect of a here? When a is positive, what type of a quadratic function do you get? What type of a parabola do you see? When a is negative, what type of a parabola do you see? Okay, right. Now, what you observe from the graph of f of x is equal to x squared and g of x is equal to -x squared. What do you observe? Please discuss for 1 minute. Right, welcome back, grade 10s. Did you manage? Did you observe something? Did you discuss? What did you see? Let me tell you what I've seen here. Right, I've seen that graph of g of x is actually a reflection of the graph of f of x. It's a reflection. You know a reflection. There's a mirror, and then you see yourself on the other side. Okay, so this line, the x-axis, is the mirror, and then the graph of f is reflected about the x-axis to give us the graph of g of x. You see that? It's a reflection about what? About the x-axis. Don't forget that. F of x is equal to x squared. If g of x is equal to -x squared, it's a reflection about the x-axis. Okay? It's very, very important. Right, because there's a reflection about the y-axis, we're going to talk about that one later, not now. Right, what else did I observe? I observed that g of x is concave down. This blue graph is concave down. Concave down is very easy to remember this. Concave down, the arrows are pointing downwards like this. They are pointing down. So when you say concave down, your arrows are pointing downwards. When concave up, the arrows are pointing upwards like that. Okay? So concave up, the arrows are pointing upwards. Concave down, the arrows are pointing downwards. Remember that. So for g of x, when a is negative, the graph is concave down. When A is positive, there's an invisible one here. The graph is concave up. This is a property which is very, very important, which is called concavity. You have to understand it. Where is the graph concave up? Where is the graph concave down? You must understand this. Very, very important. Grade 10s, I want you to spend 30 seconds to copy this. When A is, okay, I have this somewhere. Okay, I have the look. Okay, let's move on. I'll give you the notes, then you write it down. Okay, you write it down. Let's move on now. But remember that concave up, when A is positive, is concave up. When A is negative, is concave down. Remember that. Okay, I want us to look at the other effect of A. Okay, because of time, I'm going to do the plotting and then we discuss. Is that fine? Okay, I want you to learn something. If we plot, we've done the plotting, grade 10s, we've done the plotting. So if we're going to plot together, we'll need another 1 hour. So I will do the plotting, then we discuss. But if you need time, I want you to understand, all of you must understand. Please send us your questions. 063 629 3655. Okay, if there's something you have missed, 063 629 3655. Please feel free. Feel free. Right, now we have sketched the graph. Now you are almost listening. Okay, I was going to ask you to sketch this graph, but time. So now just listen. I'll try to move slowly. This is the graph of f of x on a new grid of paper. Okay, we're supposed to sketch this, but this is the graph of f of x. I've sketched it. But if you can do it fast, I'm not saying to stop doing, you can do it fast, it's fine. So we've plotted this graph. We are going to plot 2 other graphs on this same set of axes. Okay? We're going to plot 2 other graphs on the same set of axes, on the same Cartesian plane. Sketch the graph of g of x is equal to 2x squared. And then sketch the graph of h of x is equals to half x squared. Now our f of x is equals to x squared. Right, what has happened to a here? Here it is 1. You see that? And then for g of x, a is what? Is 2. So a is increased. We want to see what happens if a increases. What is going to be the effect of a? If it increases, here it is 1, here it is 2. So if it's going to increase from 1 to 2, what will happen to our quadratic function? We want to see that. And then here, a is decreased, but check, here is a fraction, so it's between 0 and 1. It's a fraction. So if a is decreased, because remember half is smaller than 1, what also happens? If a decreases, what happens to the shape of the parabola? We want to see that, and you're going to see that, you're going to observe that, isn't it? Okay, right. Now I have the points already. Okay, I've calculated the output values for g of x and h of x. You see this? I've done that. Okay, we can also do this. I skipped it because it's giving us a decimal, but this is actually 4,5. This is actually 4,5. Okay, it's not like we always skip 3. I left it because it wasn't giving us a nice value. We have to estimate. Right, now let's plot for g of x. Let's plot for g of x. Negative 2, 8. You now know x is negative 2, y is 8. We plot that. We go to negative 2 and then 8. The point is there. Am I right? Check if I'm right. Because sometimes I do make mistakes, isn't it? Check. Is that negative 2, 8? X negative 2, y 8? Yes, it is. Negative 1, 2, which is this point now. That's a point there. 0, 0. That's the point there, 0, 0, the origin. 1, 2. That's the point there, 1, 2. Do you see that? 1, 2. You see that? Then 2, 8. That's the point there, 2, 8. And then we can sketch our g of x, which is this graph here. Do you see that? Now, let's discuss this before we move on to h of x. Now, f of x is equal to x squared. Now, it was 1. A was 1. So, if A increases, what happens to the graph? You can answer that in class. If A increases, what happens to the graph? It becomes narrower. It becomes narrower. If A decreases, it should become wider. If A increases, it becomes narrower. You see that? We call that vertical stretch. It's like you're holding the black graph F and then stretching it vertically, and then becomes longer going upwards. That is called vertical stretch. Vertical stretch. Okay? Vertical stretch. So when A increases, the graph becomes narrower. So the graph of f of x is equal to 4x squared. Should be even more narrow. Is there something like that? More narrower? No, it can't be. That's English. Okay, it becomes narrower. Okay, you see that? It shrinks. The vertical stretch increases. Right. Now let's look at h of x. Let's plot h of x. I'll skip negative 3 there. I'll plot negative 4, 8. Where is negative 4, 8? It's there. Negative 4, 8. You see that? Okay, and then negative 2, 2. I skip negative 3 there, but if you want, you can say it's somewhere here. 4,5 should be somewhere there. Negative 3, 4,5 should be somewhere there, right? And then negative 2, 2, and then negative 1.5. Negative 1.5 is somewhere there, okay? And then 0, 0, the origin. I'm now here on this one. And then 1.5. 1.5, 1/2 is 1 over 2 there. And then 2, 2. This one, 2, 2. 2, 2. Miss there. That's 2, 2. Then 3 and 4,5 somewhere there. And then 4, 8. The last one. 3 and 4,5 should be somewhere here. No, that one is 5. 4,5 should be here. Then 3 and 4,5 should be here, because this is 5. This is 4,5. Right. And then now we can plot our points. You see that? We can plot our points. And then do you see that the yellow graph, which is for h of x, when A decreases, the graph becomes wider. When A increases, the graph becomes narrower. Okay, it's like almost like the gradient thing. Remember the gradient. When the gradient is small, let's say these are two graphs. When the gradient is small, the graph is more gradual, like this. But if I increase, this is y is equal to, let's say, is equal to 2x plus 2. Right, if I increase this to 4 and say y is equal to 4x plus 2, the gradient will increase. The graph becomes steeper. You see that? Something like that, because this is more gradual, this is steeper. You see that? This is steeper. Okay, so that's the vertical stretch. So if A increases, the graph becomes narrower. If A decreases, the graph becomes wider. Okay, but remember that when it decreases, it becomes negative. Once it becomes negative, you know what happens? If it becomes smaller and smaller and smaller and smaller and smaller and smaller, it becomes wider, wider, wider. And then when it becomes negative, it flips, comes this side. It's now reflected. When A becomes negative, then the graph is now reflected on the what? On the x-axis, okay? So the decrease we're talking about should be a fraction between 0 and what? And 1, okay? Right. And then when it becomes negative, it is now reflected. We talked about that. So now, we're going to use the rest of the minutes that we have, but let's just go back to what we have discussed, grade 10s. We have learned these two things mainly. The effect of the parameter A. The effect of the parameter what? A. Because we're going to be talking about the other parameters in the other lessons, okay? What does A do? If A is negative, the graph is what? Is concave down, is reflected on the x-axis. If A is positive, the graph is what? Is concave up. When A is positive, the graph parabola is concave up, the parabola to be specific. And then when it's negative, it's concave down. And then if A is bigger, the graph is narrower. When A is smaller, the graph is wider. That's what we have learned about the effect of A. Okay, right, let's just talk about the rest of the key features for these 5 minutes. Okay, the key features of what? Of the quadratic function. Right, we've talked about this. If A is greater than 1, as A increases, the graph becomes narrower. And then when A is between 0 and 1, as A decreases, the graph becomes wider. We've talked about that. Okay, let's talk about these key features for these few minutes. So we have talked about the shape. So this is a repetition. A parabola is a cup-shaped function or graph. If A is greater than 0, this means what? It means positive. Means positive. If A is greater than 0, if A is positive, the graph is what? The graph is concave up. We've talked about that. Okay, just listen now. Okay, just listen. But if you can take short notes, it's fine. And then when A is less than 0 means negative. Remember that. When A is negative, the graph is concave down. Okay, it's a key feature which is very, very important. A shape, to sketching a graph, a shape is 1 mark. Gives you a mark. Drawing the correct shape there is a mark. Then there's the axis of symmetry. Great times we've been doing lines of symmetry even from primary. Do you know that? The lines of symmetry. Okay? When I say, is this shape symmetrical? Let me draw this shape here. Is it symmetrical? Yes. If I draw the line here, you see this side is the same as this side. Okay? That's the line of symmetry there. So the axis of symmetry is like the line of symmetry. So a parabola is symmetrical about the y-axis. This one. F of x is equal to ax squared. It is symmetrical about what? About the y-axis. So this is the line of symmetry. Axis of symmetry. Now, what is the equation of this line? What is the equation of this line? X is equals to 0. Remember, for a vertical line, is x is equals to. And then horizontal line is y is equals to something. Okay? Remember that. If it's for your first time to hear this, please remember it. Let me just give you an example. Because some of you may not be knowing this thing. Let's say this is a vertical line which passes 3 to 0. Ne? So the equation of this line is going to be x is equals to 2. That's the equation of a vertical line. Horizontal line, let's say this is a horizontal line which is passing through the point 0, 3. The equation of this line will be y is equal to 3. Okay? Right. So this axis of symmetry is a vertical line, so which passes through 0. So it's x is equal to 0 for this function. Okay? Right. And then what else do we have? Or we've talked about that. The turning point. The turning point. Okay? The turning point. So this is where the graph changes direction from decreasing to increasing or vice versa. Right, okay. Like this graph here is decreasing, going down, going down, going down, going down. Okay? And then when it gets here to this point, it what? At this point, it turns. It's now going up. Going up. It's now increasing. So this is the turning point. That's where the graph changes direction. Okay? And then for a concave up graph, that turning point is the minimum value, meaning that this graph can never have a value which is less than that point. That's the minimum value. Okay? Right. And then you can have this one. The graph is going up, increasing, increasing, increasing. We use those terms. You must know them. Where is the graph increasing? Where is the graph decreasing? Then when it gets to this point, it turns and now decreasing, decreasing, decreasing. You see that? So that is the turning point. And then this point, is it going to be maximum or minimum? For concave down graph, that is the maximum value. Okay, that's the maximum value. So the graph which is smiling, you have seen some people, they talk about smiling graphs or frowning graphs. So the concave up graph is a minimum value. The concave down graph, the frowning graph, is a maximum value. Okay, like you're going up, but you can't go for more than this height. You have to come down. Okay, you have to come down. So that's the maximum value there. Right, and then we have what we call the x-intercept. We're going to be talking about these things later. The x-intercept is where the graph casts the x-axis. Let me show you. This is the x-intercept. That's where the graph casts the x-axis. Even here, this is where the graph casts the x-axis. Okay, these are the key concepts. Okay, and then, or terminology that you have to know. And then we have the y-intercept there. Okay, right. So we've learned about these things, grade 10s. The last part of the lesson, we're rushing, trying to cover a lot of things. But the main thing, grade 10s, remember our objective. What was it? We had to plot our graphs using point by point. And we had to, to learn the effect of what? Of A. What is the effect of parameter A? We found that. What did I say? When A is negative, the graph is concave down. When A is positive, the graph is concave up. When A is bigger, the graph is narrower. When A is smaller, the graph is wider. Remember that, grade 10s. Don't forget that. Okay? Right. Now, let's just summarize our lesson. We've done a lot of things, but now I wanted us to cover a lot of things, but our time is up. We're going to talk about these things in the next lessons. We're going to talk about the domain. We're going to talk about the range and all those things. Right. Now, I wish you all the best. Stay safe and enjoy the rest of your day. We are going to meet in our next lesson, grade 10s. Goodbye.